Start.
Good evening, sir. Good evening, class. My name is Ashley Gariba. I'm a part of Group 1. Tonight we will be talking about the mechanism for activation of acute inflammation. At the bottom of the slide, you can see the group members. As well on this slide, you can see the group members and their USI. So my task is to define what is acute inflammation. So acute inflammation is the body's defense mechanism. It is an essential part. Acute inflammation manifests immediately after an injury. It can be a physical injury or internal injury, or it can be trauma as well. Now, there are 5 fundamental signs of inflammation, which are heat, redness, swelling, pain, loss of function. Prolonged inflammation without recovery may lead to tissue damage and fibrosis. Now, fibrosis is the stiffening and hardening of affected tissues. And now I'll hand you over to my other colleague.
All right, thank you. And now let's go into the causes or triggers of acute inflammation. Now, the first cause we have here is infection. Now, infections would include illnesses caused by bacteria, viruses, fungi, or other pathogens. And then secondly, we would have trauma and tissue injury. These would be physical injuries like sprains, strains, fractures, and bruises. Burns, both hot and cold. The cold version of a burn would be frostbite, and this could lead to damaged tissues. And last but not least, surgical procedures, where inflammation is a normal part of the healing process after surgery, as tissues are then being repaired. All right, moving on, we have exposure to irritants, foreign bodies, or the exposure to foreign substances such as allergens, where the immune system would overreact to allergens like pollen, thus leading to inflammation. Toxins and irritants, or the exposure to harmful chemicals such as pollutants or other toxic substances, can trigger inflammation. And last but not least, cell damage, when cells are damaged or die to internal or external factors. This is called necrosis, and they would release signals called DAMPs, or damage-associated molecular patterns. And these would trigger the inflammatory response. Now let's get into this diagram. This diagram shows the mechanisms by which the innate immune system, which senses threats either from foreign pathogens or the host cell being damaged. And this would initiate the inflammatory response, particularly involving neutrophil recruitment. Now, this process is generally explained by the danger theory. The danger theory states that the immune system is activated by not just microbial signs, but damage signals from the body's own cells. Now, first on the left, we have PAMPs, which are pathogen-associated molecular patterns. PAMPs are molecular signatures found on or within microorganisms that are organized by the that are recognized by the host immune system. And these are meant to act as exogenous signals, exogenous meaning that the organism came from outside of the host body, which would be bacteria, viruses, fungi, or parasites. And these signals would alert the immune system to an infection. Now, an example of this would be lipopolysaccharide, or LPS, which is a component of the outer cell wall of a gram-negative bacteria like E. coli. Now, on the other side, which is the right side, we'd have damage-associated molecular patterns, or DAMPs. And these are molecular patterns that are released or exposed by host cells that are stressed, injured, or dying due to trauma, chemical exposure, or lack of blood flow. And these act as endogenous danger cells. Endogenous meaning that it is coming from within the host's own cells. And They activate the immune system and initiate a sterile inflammatory response, which is inflammation without infection, and also promotes inflammation and the recruitment of neutrophils. An example of this would be the mitochondrial DNA, which is released from a damaged mitochondria and is also structurally similar to DNA, allowing it to act as a DAMP, damage-associated molecular pattern. All right, great. Now you may have also noticed that on this diagram there is something being called formal peptide. They're now on both sides of this recognition pathway that we have here. Now this is because formal peptides are both released by mitochondria and and bacteria, and is then formed or bound to the formal peptide receptor 1 or FPR1. And this is found on the phagocytic leukocytes like neutrophils and plays a significant role in chemotaxis, which is the cell movement towards a signal. Now, in short, PMPs signal infection and DAMPs signal damage. And the PPR, PRRs, which would be the pattern recognition receptors on the immune cells, would recognize both to initiate the vital process of inflammation. Right, now I'll hand you over to our next presenter.
Certificate inflammation. Firstly, we have serous inflammation, which is commonly referred to as serositis. This describes inflammation of the serous membranes. Areas affected may be of the pleura, an affliction of fluid buildup causing restrictive lung disease, the pericardium, an affliction of fluid buildup around the heart causing cardiac tamponade, or of the peritoneum, an affliction of fluid buildup around the abdomen causing bowel obstruction. Secondly, we have fibrinous inflammation, which is a form of inflammation characterized by the deposition of fibrin. This occurs as a result of severe tissue damage. Areas affected may be of the pleura, an affection of constriction around the lungs, leading to pleural friction rub. The pericardium, an affection of constriction around the heart, leading to constrictive pericarditis. The peritoneum, leading to bowel obstruction. Thirdly, we have suppurative inflammation. Suppurative inflammation refers to inflammation categorized by the buildup of pus. This occurs when the immune system is fending off pyogenic bacteria. Areas affected may be of the pleura, causing lobar pneumonia, the buildup of neutrophils in the alveoli, or of the bones, an affection of pus in a narrow cavity, myelitis. Next, we have pseudomembranous inflammation. Pseudomembranous inflammation is distinguished by a thick white pseudomembrane growth, usually on areas such as the colon. It most often occurs when there is damage to a mucosal surface. This inflammation may be found as toxin-induced epithelial necrosis, in which fibrin-rich pseudomembranes adhere to the colon wall, causing diarrhea and impaired colon function. Next, we have catarrhal inflammation, which refers to inflammation of the mucous membranes. It occurs when mediators such as histamine and prostaglandins increase blood flow in the goblet and mucous glands. Areas affected by catarrhal inflammation include the upper respiratory tract, in where acute sinusitis may develop, or the genitourinary tract, in where catarrhal urethritis may develop. Lastly, we have serosanguinous inflammation. Serosanguinous inflammation is a type of inflammation categorized by the deposition of serous fluid mixed with blood cells. It occurs due to minor blood vessel damage or limited tissue destruction. Areas affected may be the skin, in the case of second-degree burns, or the serous membrane, where it may cause mild pleuritis. Next slide.
Okay, good night, everybody. I'll be explaining this diagram. Okay, so acute inflammation begins with tissue damage, such as cuts, burns, or infection. When cells are damaged, they release chemical signals that alert the immune system. These signals activate nearby mast cells and macrophages, which are the first cells to respond in inflammation. Once these immune cells are activated, these chemical messengers, also known as cytosines and interleukins, they're also known as them. Yeah. So, because mediators like histamine and interleukin 1, the blood vessel in the area widen. This process is called vasodilation. This increases blood flow to the injured area, which explains why the area becomes red and warm. At the same time, the blood vessels become more permeable, meaning the fluid and protein can leak through the tissues. This causes swelling and pressure from the swelling. Along with this is chemicals like bradykinin, and that is lead to pain. As the blood flow slows down, white blood cells, especially neutrophils, begin to move closer to the vessel wall. This is called margination. Then they start rolling along the blood vessel, and this rolling happens because of weak attachments between the molecules called selectins on the vessel wall and ligands on the white blood cells. Sorry. Next, cytokines like interleukin 8 activate the white blood cells, causing them to stick firmly to the vessel wall. This step is called adhesion. After adhesion, the white blood cells squeeze through the vessel wall into tissue. This process is known as depolysis. If I pronounced it right. Okay, once in the tissue, the white blood cells move towards the exact site of injury by following chemical signals. This movement is called chemotaxis. Okay, and they're responding from the signals produced by the interleukins and the complement proteins and substances that was released by the bacteria or the infection, right? So after that, the neutrophil is always the first one to arrive. And they just begin phagocytosis, where they engulf bacteria and damage tissue. Inside the cell, enzymes and reactive substance break down and destroy the pathogens. The macrophages then arrive to continue phagocytosis and release more cytokines that help regulate inflammation and healing. Once the cause of the injury is removed, the inflammatory signals decrease. The macrophages then release growth factors that help with tissue repair, collagen formation, and healing of the damaged area. At this stage, inflammation resolves and the tissue begins to return to normal. Next slide, please. Yeah, I'll now hand you over to the other colleague.
So, acute inflammation can systematically manifest itself in quite a few ways. The first way it can systematically manifest is through acute phase response. When this occurs, macrophages are activated and autoimmune cells release. Those are your pro-inflammatory cytokines, which are mainly the interleukin 1 and tumor necrosis factor and the interleukin 6. So these cytokines, they act on your liver and it synthesizes an acute phase protein, including the CRP, which is called the reactive protein fibrinogen, and the serum amyloid A, or SAA. When this happens in the acute phase protein systematic manifestation, opsonization makes the pathogens easier for leukocytes to phagocytize.
Increased fibrinogen causes rouleau formation of red blood cells. This raises the ESR rate, erythrocyte sedimentation rate. The next manifestation is fever, or we call it pyrexia scientifically. So the interleukin-1 and the tumor necrosis factor acts as an endogenous pyrogen. It reaches the hypothalamus and induces the production of PGE2, prostaglandin E2. In this process, the cytokines stimulate the COX enzymes in the hypothalamus. The PGE2 raises the hypothalamic temperature, and then after that, the body responds by shivering, vasoconstriction, and heat conservation, and then the fever, the core temperature of the body rises. So there's also the autonomic nervous system systemic manifestation. This is where the inflammatory cytokines influence autonomic centers. What this leads to is peripheral vasoconstriction. This is where the blood is redirected from the skin to the vital organs. Your heart rate is increased, and also your blood pressure. What this does is it helps to maintain tissue perfusion. And the purpose of this is to minimize heat loss, and it supports increased metabolic demand during inflammation. Miss Chelsea Baxter will be continuing with other systematic manifestations.
Okay, so good night, sir. Good night, everyone. I'll be continuing the other systemic manifestation. The next one is behavioral and constitutional symptoms. So cytokines also affect the central nervous system, and they would produce malice, which is basically the sense or feeling of being ill, anorexia, somnolence, which is an intense desire to sleep, chills and rigors, and these are some of the um some of the feelings you would get from the central nervous system. So these changes would also promote energy conservation, redirecting metabolic resources towards immune defense and tissue repair. Okay, so leukocytosis. Okay, so cytokines such as interleukin-1 and tumor necrosis factor, or IL-1 and TNF, stimulate the bone marrow, and it would stimulate it to increase leukocyte production and release into circulation. Patterns of leukocytosis would reflect the cause of inflammation. So neutrophilia would basically cause bacterial infections. Lymphocytosis would cause viral infections, for example, mononucleosis and measles. And eosinophilia would cause parasitic infections such as allergies and asthmas. And in some infections, for example, typhoid fever, leukopenia may also occur due to bone marrow suppression or consumption of leukocytes. Okay, so now I'll be doing clinical importance of systemic inflammatory response. So while systemic effects of acute inflammation are protective, excessive, or sometimes uncontrolled, cytokine release may lead to systemic inflammatory response syndrome, or SIRS, sepsis, shock, and multi-organ failure. And thus, the same mediators that protect the host can become pathologically harmful when dysregulated. I'll now hand over to my colleague who will be doing the conclusion.
Okay, to the conclusion. Okay, so acute inflammation is essential for an immediate defense against injury or infection. There are many types of acute inflammation, as we learned in this presentation. There can be systemic, psychological reactions to the infection, inflammation, trauma, or injury. Resolution, this is complete healing and repair. This occurs when the cause of inflammation is eliminated quickly and tissue damage is minimal. Potential progression to chronic inflammation. This happens when the acute response does not terminate the cause of inflammation. And this brings us to the end of presentation. References.